So here we've got a graph, and the graph is measuring the volume of gas produced by a reaction against the time it takes for that to take place. So the results have generated this curve here, which is drawn using the black line. And then what I've done on this graph is I've drawn tangents to show you how the rate of reaction is changing. So this first point here is the steepest, and that's at the beginning of the reaction, and that means the reaction is going at its quickest. This middle point here, the slope has started to lessen, so the gradient is not as steep, and that's the middle of the reaction, and that indicates it's starting to slow down. And the final point here, this is now starting to level out, which actually means that there's no more gas being produced, because that's going to be the same value, and therefore this reaction is actually stopped at that point. If we try and explain why using particle theory, so down here, this point here is the start of the reaction. At the start of the reaction, we have got a lot of particles, high concentration. These particles are going to be moving, and because there's a lot of them, there's going to be more chance of those particles reacting. So that's why the reaction is quickest at the beginning, because there's a high concentration, more chance of them reacting. But if we think about this, as they react, let's say this particle here reacts with this one, those particles now change into new chemicals, the products. And let's imagine this one reacts with this one. So what we end up with by the time we get to the next point in the middle of this reaction is a couple of these chemicals no longer exist. And therefore, the concentration of them has got less, and therefore the chance of those particles reacting has got less, and therefore this reaction now is starting to slow down because there are fewer particles, less chance of reaction, therefore it starts to slow down. They will continue to react, so this particle here bumps in with this one and it reacts, and this particle bumps in with this one and it reacts. And you get what's going to happen here. By the time we get to this point, we've already lost some of these other ones now start to react and disappear, and suddenly there are no particles left. So at this point, towards the end of the experiment, here now the reaction has ended. There's no more reaction, there's no more gas being produced because there are no particles left. So that explains why the graph has this shape showing fastest at the beginning, and then the reaction starts to slow down as particles react, becomes fewer of them, less chance of reacting, continues to do that until eventually there are no particles left at all. This would be the same, if I just use a different type of pen, this would be the same if the reaction was measured this way. You would still get this kind of shape coming across, which shows exactly the same thing in that at the beginning, the reaction is its quickest, and as it goes on, the reaction gets less and less and less until eventually it stops.